Yeah, good evening. So last session we started discussing about functions. We learned about parameterless and parameterized. So how we can configure parameterless and parameterized. So after understanding parameters and parameterized, we learned rest parameters also. Rest parameter means one argument allows multiple. One parameter allows multiple arguments, right? Next, another important in functions, we have to know about function return type. Function return type. Actually, function can be void type. It can be void type. So void type means you can define a function that will discard the return value. Discard the return value. What does that means? I will show you. So you can also define function to return any specific value. You can also define function to return any specific value. So function can be void and you can define to return any value. Actually, we return a function, some name like this, and this is actually void. So if you want to return, so function, so name, and it will use a keyword called return, jump statement, and value. Like this we define. Now the question is, what is purpose of this return? Is of that return. Why we have to use a function with return? So the concept is actually, I will give here, a diagram. See, suppose we are writing a function like this. Function, some add a comma b, and c is equal to where c is equal to a plus b. And we are printing that. We will print it later. Now here, in this situation, what happens is, when you define like this, now for this function, memory is allocated. So this is actually function memory. This is the function memory. So memory is allocated for the function. In this function memory, two references will be there, A. Another reference will be there, B. We will have A and B reference. Because A and B belongs to function. What about C? C is a variable you declared. Even you declared a variable inside function, this variable will not use, it is in the scope of function, but a separate memory is allocated for that variable. That means now you have a variable, that means variable memory. In that, the C will be stored. That means the function memory is handling A and B, and a separate variable memory is handling C. That means you need the memory allocation This is memory allocation. We need two memory allocations, one to store AB and another to store C. C is in the function scope, but it is using the memory separately, allocating the memory separately. So that means we are using different memory allocations for a function. That means A, B, and C. Now, what is problem with C is a separate variable memory, and memory is overloaded with a lot of things now. For example, in a function, different values you configured for everything, separate memory is allocated. Now, what we can do here is we can write a function and add A and B. And here we can simply put return A plus B. I am not declaring a separate variable. I am just using return A plus B. Generally, many times at learning level, people think that return is returning a value. How it returns a value? Return is a jump statement, right? Return is a jump statement. That's what we learned. Return, continue, break. These are what kind of statements? Jump. Return is a jump statement. How it returns a value? So return is a jump statement. So now what is happening here is, so it will perform A plus B. It will perform A plus B, and the result of A plus B will be stored in this variable in the function memory only. Understood? That means actually this is the memory for function. So that is the memory for function. This memory is for which one? Yeah, let's keep it here, right? So actually this memory is for add. For add function, the memory is allocated, and in that A and B are stored. Now what happens is, this function is using the memory for A and B. Not only that, whatever result is returned, that result also stored in the same memory. The result also stored in the same memory. But that memory reference will be this add. Understood? The memory reference will be that add. That means A and B, two different values. For add, the memory is allocated for this complete function. For this complete function, memory is allocated. The returned result will be stored here. That means add contains A plus B. That means, are we allocating any separate memory? No. Whatever function memory is there, the same memory is used for the result. That means what is difference between previous and now? Previously, we need several memory allocations. But now the function works in two ways. It is doing the addition and it is storing the result also. Previously, function is doing the addition and it is storing result in some another location. That means now in one memory, you can handle all the operations. You can handle the operation, you can store the result, both you can do. A separate memory is not required to store the value. Previously, to store the result, we need to use a separate memory. But now, without using extra memory, the result can be stored in the same function memory. That means function works as a variable as well as a function. That means it will do the functionality and it will store the result in the same name. That means where A plus B is stored now, A plus B is stored under the name of add. That means add is working like a function as well as a variable. as well as a variable. That means you see now here, let's go into the project. And here I will add, right. And here I will add a simple function here. Function is a add into that a comma b, and it return a plus b. Now what we have to do is actually we pass add 10 comma 20. That means it will do 10 plus 20 the operation. That means it will do this operation and it will store that result here. That means a separate variable is not required. It will do that work and store the result in the same. That means now where is the output? 10 plus 20 means 30. Where is that 30 stored? In this add? You have to print this add now. That means it's a function as well as it is working as a variable. That means now how to print it? Document dot write, and here we will print that add. Understood? Because this is now a variable and a function both. That means I will give here just as addition, so is equal to plus that. So, and you can see it is going to print the addition of those two values. It will display here. That means it is doing a functionality and storing the result. So what is the advantage here is you can use the function memory for handling the result. You can use a separate memory or you can use its own memory. What is advantage? You can reduce the overhead of memory. That means instead of declaring several memories and storing your values, function related all values can be stored in the function memory only. That is good. You can do any operation and finally you can store the result inside function itself. For example, see now, that means how we can handle that, right? I will copy this. This is example. Now you see here. That means what return is doing here. So after allocating memory for the function, so it is stopping the execution. Return means jump. It is stopping the execution and result is stored in this result. That means no new memory is allocated. The same memory is used for the function, right? That is the reason return is not returning value. Return is terminating. And whatever returned value is there, it will be stored inside that function memory. You can do any work. For example, see now, suppose I want to do some manipulation and return some result. Then see what we will do here. Suppose I am creating, right? So we are creating here a doc type HTML head and title. So here I will configure some option. Just I will give as login. And here we keep the body. And here I'm adding data list, data term, and username and data definition. Suppose text box input type is equal to text. And data term another, yeah. So is password. So data definition input type is equal to password. And here I am defining data term as verify code, right? And here I will put a span, but I will keep a button. So we will put a button here. Yeah. In that we have a span. So here effects later we will give bootstrap data definition id as lbl code. Okay, right. And we have a button say login, and here we will link relation is style sheet and href. So node modules, bootstrap icons, font, bootstrap icon css. We will apply the class as we have bi sync. A sync is there some light arrow, what is there, bi arrow, okay, 60 degrees, some clockwise, counterclockwise, clockwise. Okay, this is the design actually. That is the design. So in this I will just keep some style. Okay, and data definition, so margin bottom as 10 pixel. So fine. Now what should happen here is verify code. Here I want to display some random code, just like captcha, right? Then what we are doing is we are writing a script. In that we are defining a function called captcha. This captcha function will use a math dot random, will return a random number. So it is a mathematical function in JavaScript which will return a random number. Random number actually every time a new number will come, but random number starts with 0.76. That means it is having decimals. So then we will put into 10 so that it will return a perfect integer 1, 2, 3, 4 like that. Similarly, I will copy 6 numbers. Let's say A, B, C, D, E, and F. 6 random numbers. After that, we will create a code. In this code, or we will simply put an option return. Return, I am using a string type here. Sometimes random number will also return 1.7, 1.8 like that. Then we will use math.round. Round means it will round the value to nearest. 1.8 means 2. It will. So like that. So first number space, second number space, third number, fourth number, fifth number, and sixth number. All the numbers will be random. Okay. Now what happens is it is doing this work and storing this result inside this function name. That means where is captcha? Captcha is under captcha name. Where is the random number? You created a random number, but where is that number stored? It's not stored in a separate variable. It is stored inside the function memory on. Under which name it is stored? Captcha. Then what we will do is we will use here body onload. Onload is body load. So here we are writing function body load. On body load, we will get document dot get element by id. This is lbl code dot inner html is equal to, here we will put a simple option that is captcha. We will just call that captcha, because what this captcha will do is it will generate a code and store that code in that name that will be displayed inside lbl code. Now I want to do this. I will cut this and put another function as new code. This new code have to do this. On body load, I will call new code. Not only that, on function refresh click also new code should come. That means refresh click should work when user clicks this button, right? On click is equal to refresh click. That means now you can see a random code is there. I click on this refresh button, another code will come. Every time a random code is generated here. We are creating a random code here. We are generating a random code. So this is how we can configure. We can verify this code, ask them to enter that code. That means what we do under this, again, we can put data definition, input type is equal to text. You write that logic. Means here they have to enter this code. And when they submitted, when they finished blur, it should verify the number they entered is matching with this or not. If not matching, show a message that invalid code. Otherwise, verified. You try that logic. Now, where is that code? Code is already stored in a variable. What you have to do? You have to collect this value and compare with that code. And if it is matching, verified. Not matching, invalid. That you implement. So here, our intention is do a lengthy operation and whatever result comes, store in the same location. Don't use some external memories for storing the result. That will be easy and faster for a function to access the values. But sometimes we don't want to use the same function memory. Then we create it as void. That means what happens if you don't use return type? If I don't use return type, then the memory is allocated for function only to do some actions, not to store value. When a function is ready to store value, when it is using return, when you define some return type, it is going to store a value. When you define return type, it is going to store a value. If you don't define return type, it will just do the function. Then where to store the result? Some other memory you allocate and store the result. This is one example for understanding that concept. Why a function needs return. In various occasions, we don't want separate memory. We want same function memory. Then we can go with this concept, function with return type, right? This is one concept you need to understand, function with return type. Next important, we have to know about another anonymous function. Anonymous function. Anonymous function. Anonymous function means it defines a function without name. Anonymous function means a function without name. That means generally we define function without name. So let's add function.html. Here just I am defining a script. In the script we have a function and there is no name. There is no name for the function. So document.write. So I am printing hello. There is no name for function. This is called anonymous function. Then how to access it? If it is not having a name, then how to access it? Anonymous functions are defined in a parenthesis. Anonymous functions are defined in a parenthesis. That means a parenthesis like this, brace. Now we access anonymous function. It is there. Anonymous function is there, but it's not working. Then how to access an anonymous function? If it is not having name, how to access? we have to access with an empty parenthesis. An empty parenthesis is used to access anonymous function. Wherever you see anywhere I am using an empty parenthesis, it is using an anonymous function. So you see it is working. We have to access. Actually, you have seen, I will save this. This is function 3, right? Yeah. See, actually, we have seen that in different occasions actually. So where we used this anonymous function actually where some products is equal to new array. After array, why you used an empty bracket? What does that mean, Sandra? Why you are using an empty bracket? What is the meaning of that? You have done that in various occasions. Some now is equal to new date, right? What is that empty parenthesis actually? Actually, generally, every function, generally, the array that you are using, array or date, actually they are designed like this, class array. So you are using a array class. In this class, we actually have a constructor that I will tell you in OOP concept. This constructor is an empty without name. What is the responsibility of this constructor is, it is responsible for constructing array, creating an array object. It is responsible for creating array. An array is created by this constructor. When array is created, then memory is allocated and you can store all the members of array inside. That means a constructor is responsible for constructing an object, and constructor is an anonymous. Then what we do, we write like this. What we do, we write array. In that array, to create an array object, we have to use empty parenthesis. And this is why we call as array constructor. Array constructor, that empty parenthesis is a constructor. It is responsible for constructing an array. What new is doing? After constructing array, new is allocating memory for array. I told you not dynamic memory allocating operator. Construction of array is done by that empty parenthesis. Allocation of memory is done by new. That means you are constructing an array and loading into memory. That is the meaning of that line actually. So that empty parenthesis is nothing but anonymous function. Why we need anonymous functions? Already we used anonymous functions. In various locations we used anonymous functions. Actually, anonymous function is used in callbacks. Anonymous function is used in callbacks. Already we used it. For example, if you remembered, I told you about yesterday itself, we saw one option, right? So we created one REST parameter like concept. That means suppose we have products, let's say like this. Suppose we created a function. In this function, we have verify. In the verify, we have password, we have success, we have failure, right? Like this we define. Now what we have done, whenever we call verify, we have to pass password. After that, we have to use a function. And here, no name required. Why no name required? Because already this is stored in this name. Then If you try to write name here, it is invalid because now it have a reference name. So when you call it, when you pass actual value, it should not have a name. That means already you saw this. We have another function. There is no name. Now doubt is if there is no name, how they will work? That is what callback is. I told you that they will work according to situation. If condition satisfied, one function will execute. Condition not satisfied, another function will execute. That means generally anonymous function is used in callback mechanism. What is callback? Yesterday we discussed it. Callback means a function will execute according to situation. We don't call manually. Situation wise functions will be called. Which function will be called? That depends on situation. In such cases, functions don't have name. So you use it everywhere. You used this in fetch also. You used this on fetch also. That means when you worked with fetch, fetch uses an URL. After that we used an then using an function. Is there any name there? So it is anonymous, right? This anonymous function is accepting response parameter and it is returning what? Response.json. So it is not having name. That is anonymous function. So that means in which situation we have functions without name? In callbacks. Because there you don't need to call functions by name. They will execute automatically. Constructor is also that. Constructor is a function which executes automatically. We don't need to call it. That is the reason it is not having any name. So these are very important points. There is another technique actually. Anonymous is written in another way. That means suppose we defined a function and this function is so document.write. So welcome to functions. Like this I define. Now this is not having a name. Then we can store this under a reference. Some welcome is equal to that name. This is also anonymous, but this time what is difference between previous anonymous and this anonymous? Previous anonymous you have to call it immediately because you have to use empty parenthesis, where that empty parenthesis immediately after function. Suppose I want to call somewhere else some other time, then you can't use empty parenthesis. That means previously we used an empty parenthesis. Suppose we return a empty function. So this function document.write, it is printing hello. How to access this? You can access here itself. Later somewhere else we want to access, not possible. That means somewhere else if condition so a equal to some a equal to 10, then I want to call that empty, it will not work. That should be called only immediately after the function. But what is advantage of giving a reference name? You can call that welcome anywhere and use it. So anonymous functions are defined in two ways. A direct anonymous function which is called immediately, and a anonymous function with a variable reference so that you can store in memory and you can access anywhere. Still, welcome is not function name. Welcome is only variable name. Right? That is another technique. That means how do we access this? Just we have to access welcome, just parenthesis. What does this means? In welcome memory, anonymous function will be called. Understood? That is the meaning actually. In the welcome memory, this empty parenthesis belongs to this function. We are calling an anonymous function. So you can call from anywhere, any number of times. So this is accessing anonymous function. right? So anonymous functions can be defined in several ways. This is another example for that. You can store in a variable and you can access with that reference, right? This is functions without name, right? Next important, in JavaScript you have to know about function recursion. So what is function recursion? Function recursion is nothing but it is a technique. It is a technique of calling a function within the context of same function. Calling a function within the context of same function. It is a technique of calling a function within the function. Generally, function is called outside. We have to call a function within the context of that function. This is called recursion. Generally, why we need that? That means we have a function. So function is some f1, and what we do is we call this function inside the function. This is recursions. Why to call a function inside the function? So actually recursion, it is used to design batch operations. It is used to design batch operations. Batch operation means generally in computer technologies, so many batch operations will be there. Batch operation means one work is done infinity of times. Without a loop, it can run infinity of times. That is what batch operations are. Actually, batch operations means you can do the work one after another automatically. For example, see here, suppose I will open this command prompt. Okay, here I am using dir. Dir is a command. It is used to display disk information. That means list of files and folders. Now we have date. It returns a date. We have time. It returns a time. Right now, I want these three things to do every day regularly. Then what I can do is I will create a file, copy con some job.bat. Batch files will have extension .bat. Copycon is a command used to create files from command line. From command line, you can create files by using copycon. Here I am writing first date, okay, yes, overwrite, then time, okay, then date, dir. These three commands I am writing and close. One file copied, one file created. Now, what is advantage of creating such batch files is, what is the batch file name? Job. When I run this job and hit enter, now it will execute date, it will execute time, it will execute dir every time. Whenever I want that job, date, time, dir. These are called batch operations. These are commonly done. You may not know about operating system programming and all. These are all operating system programming actually. That means in your computer, you might have seen so many times when you install any software, several windows will pop up sometimes. In that windows, commands will be running automatically. And finally, it is saying that installed successfully. Those are all batch operations. That means a sequence of operations are done whenever you install a new software. You don't need to do that. They will do automatically. These are called batch operations. In these batch operations, actually, we want, suppose, dir. Dir is running one time. So you observe carefully. Suppose there is a command called ping -t. 127.0.0.1. This is IP address. And this command, you can see it is pinging to the server and verifying server is responding or not. So what is this ping? It is a batch command. And see, it is continuously testing the connection with server. That means it is verifying whether my server is responding or not. For example, you are working in a network and you are using internet on your laptop. Suddenly internet not working. You complain to some hardware people that internet not working. First, he will test this ping. He will come and see on your machine. So is server responding or not? And see here, it is continuously running. When it will stop? When I use Control C, it will stop. When I use Control C, it stops. It says that 54 packets sent, 54 received, 0% loss. That means never disconnected. It will show all the information. All the information what happened. Actually, when it will stop, if I don't use Control C, it will never stop. How to write program for continuous until you leave it for 1 year, it will be running 1 year. We return for loop, I less than or equal to 100. It will run 100 times. 1 million, 1 million times. Suppose I asked you to print numbers 5 minutes. In 5 minutes, how many it can print? It can print. How to do that? We don't know, right? That in 5 minutes, how many it can print? We don't know. Then how to write programs for such situations? For that, we need recursions actually. Recursion means it's not a very complex logic, very simple. See, I'm just using again copycon. I will say test.bat. Okay. In this, I will use dir. I am overwriting. There is already that file overwriting. After dir, what I am doing is I am writing test again. Oh, let's write another file. Copycon test.bat. Okay. dir. After that, again test. After that, so close. That means here only I written 2 lines. First line is it is running dir. After that, it is using the same file name inside the file. That means what is that file is doing? That file is running dir. That means what is happening here? This after dir, this file will run. And this file contains dir. After dir, again file will run. This means you written only 2 lines which will run forever. That means we are calling the file name within the file name. This is called recursion. That means you see now, I will just run test. Okay. Enter. It will continuously run. It will never stop. How you created such loops which will never stop until manually stop? That means do I need to write 100 times, 500 times, million times? Even you write million times, after a million it will stop. But how you can write in such a way that it runs forever? Generally, load, speed, all these are tested like this. We write batch programs. Now I press Ctrl C, then only it will stop. It is asking, do you want to terminate batch job? Yes, I want to terminate the batch job. Then it will stop. So technically, this is called batch operation. So you may be new to this word batch operation, but they are everywhere. Even softwares like MS Word, Excel, they also use batch operations. We call them macro. We call them as macros. Generally, we use such batch operations to do a set of tasks repeatedly. How many times to repeat, I don't know. Until the satisfaction happens, repeat. There is no limit of repeating. This is what recursion is. So it is a technique of calling a function inside the function so that it repeats until the condition is satisfied. A simple function called factorial. We are writing a function called factorial. So this factorial is for n. I am using if n is less than or equal to 0, then it should return 1. Means it should return true. 1 is true. And here else what should happen? Else here we have to define directly. So it should return. What it should return? So factorial, it should return factorial of n. So that means here n into factorial of n minus 1. That's how we define. That is the simple logic I written. Now what happens is, in this logic, that means whatever the logic you define. In this logic, what happens is, suppose I entered the factorial of 5. Like this I entered. If I entered factorial of 5, this 5 will be passed here. It will verify. So it is not equal to 0. Then it will go here. So what is the value of that here? It is 5. After that into the same function is called again. That means it will call factorial of 5 minus 1. That means how much it is? 4. That means now what happens? This function is called again. It is called again. When it is called again, then it will come here again. So that means 5 into 4, how much it is? So it is 20. Am I right? After that 20 into, so we will have 20 into, again factorial of already it is 4 minus 1. That means it will be how much? 3. That means this will repeat again. Am I right? That means this time what will happen? This time it is happened 23 is how much? 60. 60 into factorial of 3 minus 1. That means it will be 2. Right? This is how it happens. So that means it is going to repeat again. This time 60 into 2, 120. After that factorial is 120 into 1. That means 120. After that 1 minus 1 is 0. That means it will stop. That means now here I am just using document.write. I am saying here factorial of 5 is how much? Just we can access that factorial. Into that I can pass 5. Now you are not writing a loop, but it is rewinding again and again. How many times? Until it is 1. 5, 4, 3, 2, 1. And 5 into 4 into 3 into 2 into 1. And finally the result also stored in factorial on. Because you use it return, that means the final result is stored in that as a variable, factorial. You don't need a separate variable. So that means now it is going to print the factorial of 5 is 120. Suppose I said factorial of 6 and it is 6. Then it returns factorial of 6 is 720. It will do that loop again and again until the condition is satisfied. That is what actually the concept of, so how we can handle the batch operations. This is called recursion. So recursion is a technique where a function is called within the function. We call this mechanism as recursion. That means when we are not sure how many times it should repeat, It should repeat until the conditions will match for it. In that case, recursions are good. We can do lot of batch operations using this recursion type. This is called function recursion. How we can call a function inside another function. That is important. Another important is we have function closure. Function closure. Function closure is nothing but actually closure is a technique. Closure is a technique of configuring a function within function, configuring a function within function. Not only that, and making the members of inner function, the making the results, right? Making the results of inner function accessible to outer function. Generally, they are not accessible. The values of outer function are accessible to inner function, but the values of inner function not accessible to outer. Making it possible is closure. That means closure is a technique of defining a function here, function. So parent, in this function, we have where some x equal to 10, x equal to 10. In this, we have another function. This is child. In this child function, we have some y is equal to 20. And here I am defining where z is equal to x plus y. It is possible to access the outer values in inner. It is possible to access that. But how to access that z and display outside? That means where a is equal to z into 2, like this I given. But this z is not accessible outside because it is inner function. Then how to access that outside and use? So that means, for example, I say result, how to access it outside? Then what we can do is, we can make this child function return z. Or directly what you can do is, you can simply write here return x plus y. Am I right? That means return x plus y means the result will be stored in which location? The result will be stored in child. And that you can access here. We can access child into 2. Understood? That means the result of an inner function is accessible to outer function. Is accessible to outer function. And we are doing some operation on that. That means I say 10 and 20. 10 plus 20 is 30. 30 into 2. So that it is actually performing. That means outer function values are accessible in inner, but inner values are not accessible outside. Then we have to follow this technique. What we have to do, make the inner function to return result. And whatever result returned by inner function, it will be catched by outer function. Whatever result returned by inner function, it will be catched by outer function. And you can do one more here. What you can do is, you can return this values. This is correct closures. That means now finally the result is stored in parent. The value of inner and outer functions are stored in parent. This is called closures. So a closure technique allows to access the members of inner function to outer, so that outer can use the inner values. Now, how do we print? Just document dot write some result is equal to whatever parent is having. The parent is having. That means whatever parent is having, it will display. This is the technique of accessing the values of an inner function in outer function and using those inner function values in outer function. This mechanism is called closures. We call these as closures. So that is what actually function closures are. So this is an example for closures. So function parameters, parameterless, rest parameters, recursions, closures, anonymous functions. These are all various function types. Another important, we have the concept called, we have so a concept called arrow functions. Arrow functions is nothing but it is a shorthand technique of using function. Instead of writing lengthy way, shorthand technique of writing function. These days in modern JavaScript, everywhere we use these arrow functions regularly. So that means it is a shorthand technique of writing function. That means how actually, suppose we are writing a function, hello, this function is returning. So yeah, this function is returning some hello. That is a string. Actually, what you can do is this lengthy can be defined in a shorter way. You can do it in a shorter way. How you can define in a shorter way? Actually, see, I am writing a var welcome, and here equal to, this is an empty parenthesis and implies, and here I say hello. That's it. I will write this some welcome like this. This is how we can write a function. This indicates function parameter. This indicates function return. The function return. So this can have a parameter. That means parameter means, suppose I am defining user is equal to, so user details is equal to, you can get here a message, username, and implies you can say hello, that username, like this we can write. That means this is parameter, and this parameter will be printed here. That means now what we are doing, suppose I want to print welcome, then what we do, document.write welcome is a function. That means it is going to print that welcome. I want to print the user details. Then what we will do, document.write user details. User details is expecting a parameter, username is John. And you can see it is going to print welcome, hello John. This earlier we have to write in a lengthy way, function, parameter, and return, and hello, that username. This all you can now wrap in single line, means in a simple way. So wherever you need lengthy functions to write, you can use in a shortcut technique. This is called arrow technique. Arrow functions you can use everywhere now. See, actually this is example. Already wherever you are using callbacks, you can use that. Suppose I will say function F1. Okay, this is okay, fine. I can even write like this. So var F1, or say, suppose I say print products. Print products is a function. That means we define like this, implies. And what this have to do? It should fetch. I'm using fetch from http colon. So fakestoreapi.com/products. Okay. After that, what we do then is a callback function. You don't need to write function. You have to just write response implies response.json, implies response.json. You can write like this. That means then is using a function parameter response, and implies indicates it returns response.json. Implies means return. Now what should happen? So response.json. Now again, then this time we have to collect the data. Data is parameter. After collecting the data, we need to print the data. This is a simple result. That means how to print for var item of data. We have to just print document dot write. So item dot title plus br line break. Now how to call these print products? Just we have to call print products as a function. So now you can see it should able to access those products list and display from the API. Spelling wrong, response.json. It should able to get all the response details and return. It will get all of them. This time we are writing in a very short technique. This is called arrow technique. These days in modern JavaScript, you will see everywhere like this. That means nobody writes function word. So, and defines parameters and all. It's a simple technique. This everywhere. So everywhere we have the callback technique using arrows. That's how we define arrow functions, how we can configure. Later in all programming, we will see means how to use arrow functions in different ways. But this is all about the concept of working with functions. Now, once we know all these functions, now we need to go into JavaScript OOP concepts, object-oriented programming. Okay, that we'll see next session, right? In the next session, we will start learning about OOP concepts. So that will be again on Monday, right? Tomorrow, no session. Again, Monday, we will have this concept of OOPs will start. Okay.